Now to homoskedasticity. So what is homoskedasticity and why should I care? So the variance of our residuals should be constant across all levels of the predictors. If we find that our residuals fan out or funnel in, we're going to have heteroskedasticity. What it's going to do then is affect how confident we are, our confidence intervals, and ultimately our p-values, suggesting that they might be unreliable. So imagine the idea, and while it may be terrifying, but it actually should probably resonate, the idea that your car's brakes be working equally well at any speed. Let's say they work great at 30, but lock up at 70. Your ride's going to become unpredictable, and then we're going to have something that we're probably not feeling very confident in. So we want our model's residuals to behave consistently, whether our predictor is slow or whether it's fast. And the way in which we go about this is we do the same exact process that we did for linearity. We're going to go to plots. We're going to plot the Z predicted on the X and the Z residual on the Y. So those are the Z scores. And we're going to look for, in the plot here, right there, of these regression standardized residuals against the predicted values. What we're looking for is a rectangular shape, an even vertical spread. So we want to avoid fanning. We want to avoid funneling patterns. And ultimately, by the visual inspection, we can see that for the most part, it's lining up to be fitting out like a rectangular shape with even vertical spread. We don't see any funneling patterns, nothing fanning out. So we feel pretty good about checking out homoskedasticity. Worth noting that you can maybe consider relaxing homoskedasticity when you have large sample sizes, which makes standard errors more robust with heteroskedasticity when you're using robust standard errors. It's not okay to do so, though, when you're doing inference with small samples. Confidence intervals and p-values can be misleading at that point, or when variance changes dramatically with X making predictions unstable. So ultimately what we see here, the result is that we pass a visual inspection, so we feel good about our assumption with homoskedasticity. Now to collinearity. Multicollinearity is when estimators or predictors should not be highly correlated with each other. So multicollinearity is going to make it hard to isolate the individual effect of predictors. It inflates standard errors, making it harder to detect significance.